저는 현대중공업에서 선박의
Heavy industry, I worked on ships design information and ships fuel efficiency research activities. Now I am working at Hyundai Global Service. I use the actual vessel data to provide smart ship solution digital platform. So we apply digital technology to decarbonization. Today, in the session titled Maritime Digitalization, I am going to make the first presentation about how we have applied our shipbuilding knowledge to digital platforms for smart ship solution. And I will also take examples of commercial services and give you interpretation of smart ship solution in the maritime industry. First of all, I would like to share with you the keywords of maritime digitalization trend. In the shipbuilding and maritime industry, the keywords are economicality, safe operation, environment friendliness. In order to ensure economicality, we are increasing the size of vessels, and in order to ensure stable structures, we are updating the relevant rules. And infrastructure in canal or channels are also being changed, and environmental issues have become all of our task. We have to meet the environmental regulation. In order to reduce the emission from vessels, we have to use environment-friendly fuels and draw up the most optimal operation of vessels. These are the challenges we are faced with. In terms of the design, shipbuilding of ships, and in terms of operation and management of ships, we need to apply optimal technologies. So we are applying digital technologies to achieve optimization. These are the platforms we use, which are called smart ship solutions. Among them, ICT-based smart solutions are applied to vessels. Those vessels are called smart ships. Through digital data, the controllers can receive help for making decisions, efficient decisions. From data to decision making, the process is enabled by ICT, and such ships are called intelligent ships. And shipbuilding industry and maritime industry are cooperating with each other to realize intelligent ships. So the whole vessel components are applied with ICT technology-based decision making. Such digital technologies are combined with networking technology and AI technology and are leading digital transformation in vessels. And data between vessel and onshore control center is efficiently being shared. They're connected with each other. And data is stored and complemented in the cyberspace. Such a network is being stably established. And as for AI is applied to image signal analysis, and predictive maintenance and automation control are also possible through digital twin technology. These are onboard equipment. Onboard equipments are also being digitalized. They are composed of navigation equipment, propulsion equipment, and other ship operational equipment. There are smart solutions that are helpful for controlling the onboard equipments as well. And this is the data being shared between onshore monitoring center and vessels. So in the onshore monitoring or controlling center, they can receive ship operation related data on a real-time basis through satellite communication, so they can manage the status of ship and fleet and monitor their status. As such, we can collect and share information between people and systems. And we have big data system. Through big data collection and analysis, we can analyze situations. Such intelligence is being realized, and based on the analysis of data, we can predict hazardous situations and take actions in advance. So systems on board include situational awareness system, planning system, and control system. These will be automatically realized under the autonomous technology. And commercialization of technologies are being proceeded with, and there are smart ship solutions where such technologies I explained before are being actually commercialized and applied. So this is how I categorize the technologies into different sectors. First of all, we have digitalization, which measures operational data and image recognition. And we have equipment automation technology, economic operation technology, and onshore monitoring technology that supports remote inspection, and digital twin technology that enables remote inspection and support. And in order to minimize emissions and comply with the GHG regulation, we have the smart ship platform named regulatory response. And in order to minimum sailor operation and ensure safety, we have autonomy platform technology. So the common issue is how we're going to preserve the Earth environment and make contribution to the better life of human beings. Now, different industries are being converged with each other and experiencing digital transformation. I'll briefly explain about each platform. The first platform, which you may often experience, is smart ship solution based on digitalization and economical operation. We apply IoT to vessels. This is the most representative digital platform. There are many such solutions launched in the market and are already being applied to vessels. Data related to ship operation is collected, and AI machine learning technology is applied to intuitively analyze the data, and the analyzed data is shared with the onshore system. And we can also automatically create reports for the ship operating companies, and potential fuel saving and other fuel related information can be also analyzed. So we are providing such optimal systems and guidelines. The next item you often see is AI-enabled camera image. This is a navigation support system. At Hyundai Heavy Industry, we have in-house venture, Aricus, which commercialized this technology, including AD, AIS, and VDI. We receive various images, and through deep learning analysis, we intuitively provide the information which may be missed by the navigator. Another solution is the Onboard Solution. We offer integrated smart communication system. So various communication equipments can be managed in an integrated manner. It can reduce the number of cables that connect various systems, And next one is related to decarbonization efforts. From 2023, CO2 emissions regulation will take effect. So this is a solution to help us respond to this regulation. It does the logging of ship operational information. This solution enables automatic logging of fuel usage information. It also provides the optimal RPM or routes to comply with the regulation. So it proposes optimal ways of operating your ships to comply with the regulation. Next is another solution to achieve decarbonization. Now we are moving towards LPG, methanol, and LNG that are environment friendly. So it is important to monitor integrated automation system, and not only cargo-related equipments but also new equipments need to be controlled properly. And this is the platform that controls such equipments. Onshore monitoring. So we collect data from vessels and share it with the onshore system. It supports data sharing between ships and onshore control center. So from onshore center, you can monitor the ship-related information on a real-time basis and identify the status. The HIFO-S is the onshore control system. This is realized in the form of website, so customers can easily identify the situation here. So far, we have shown you the solutions that you may often experience in the market, and next are related to digital twin, which exists in cyberspace. So digital twin is the technology where you can reproduce the physical system in the cyberspace. You can also reduce the latency between vessels and the onshore system through the digital twin technologies. In the case of digital twin technologies, they provide support for ship design and commissioning management. We have seen small success stories from the development of digital twin technologies. Hyundai Global Service and Hyundai Heavy Industry have already developed or launched the products. Many companies in the market are launching various solutions that are equivalent to the solutions we have. In the existing shipbuilding industry and maritime industry, we accumulated our knowledge. These platforms move beyond those knowledges and actually realize those knowledges into reality through technologies. As time goes by, we will be able to implement these solution technologies into reality. Now, I'm talking about technology, fusion, and the transition towards digital platform technologies. So based on the knowledge we have, we are applying and realizing technologies to various services. So we can call this process knowledge-based service industrialization. With the development of infrastructure environment, including communication and data network, such technology is rapidly being developed. Telecommunication is one of the most important issues. Tomorrow, we will launch the Korean satellite Nuriho, and we have rapidly developed the satellite telecommunication technologies. And The legion area will soon be eliminated across the world with the development of satellite telecommunication technologies. With the rapid development of digital technologies, we will also see the accelerating development of digital twin and relevant platforms. Now, digital twin technologies are not perfectly integrated with each other. In different sectors like operational equipment, we have seen small success cases, and the industry participants have agreed on the direction of digital twin technology, and R&D is being conducted actively. So people can receive the optimal assistance from the digital twin system. So people's intervention will be minimized in the future. So starting from the commercialized digital platform to the autonomous ship technology and digital twin technology, I have covered the technologies we have been developing. Through maritime knowledge, we are moving towards digital transformation in this sector. As for failure diagnosis and predictive maintenance, digital platforms are helping us enable such activities in a more improved way, and we can also ensure stability and ensure environmental protection. To achieve this, technology fusion or technology convergence is going on, and such trends will be accelerated. So this will be all for my presentation. Thank you for your attention.